In this podcast episode, Dr. Andrew Huberman interviews Dr. Matthew Krummel, a prominent immunologist and cancer biologist, about the immune system's function, its complexity, and factors that influence its performance throughout life. They explore the immune system's development, aging, and spatial organization, as well as its relationship with the nervous system. The conversation addresses why sleep is critical for immune health, the intriguing role of the thymus, the nature of autoimmune diseases, and current perspectives on vaccines and immunotherapies. Additionally, Dr. Krummel offers insights regarding scientific discovery, public education, and the future of immunological research, including the contribution of computational tools in advancing the field. Dr. Krummel reflects on his beginnings in immunology 3 decades ago, when the field was considered nascent and primarily molecular. Early views framed the immune system straightforwardly as a defense against foreign invaders, which had to remain passive without threats. The advent of cancer immunotherapy challenged this self versus non-self paradigm, revealing that immune cells can be fine-tuned to attack cancer cells that are neither fully self nor totally foreign. This widened the conceptual framework to include a tunable system capable of diverse and context-dependent responses. Over time, it became clear that immune cells, especially T cells, are not just defenders against pathogens, but also play vital roles in tissue maintenance, regeneration, and managing resident microbes. Dr. Krummel emphasizes the immune system's profound integration within organs such as the gut, liver, heart, and brain, acting as both a sensor and regulator to maintain equilibrium and overall health. The immune system undergoes critical changes from infancy through old age. In newborns, immune function is limited and relatively suppressed for several months to prevent harmful self-reactivity during rapid development. As children encounter environmental microbes and pathogens, their immune system learns to identify threats and build resilience, resulting in frequent but transient illnesses. Conversely, the aging immune system faces a gradual decline in production and functional capacity of immune cells due to diminished stem cell activity and accumulated cellular mutations. This mosaicism in body tissues complicates the immune system's ability to distinguish self from altered cells, contributing to increased incidence of infections, cancer, and autoimmune issues. The reduction of thymic output over time, where new T cells are educated, creates a vulnerability as fewer fresh immune cells enter circulation with age. Dr. Krummel explains that the evolutionary pressure for immune efficiency diminishes beyond reproductive age, which may partially explain the decline in immune robustness in older adults. He also highlights the protective anatomical niches for neural and stem cells, such as the brain and bone marrow, which limit their exposure to mutagens, thus preserving critical functions throughout life. An illustrative wartime analogy compares World War II submarines' acoustic identification to immune recognition of self and non-self as a framework to understand immune discrimination challenges, particularly with aging. In youth, the immune system has a relatively distinct sound book representing normal self proteins, making recognition of foreign proteins easier. However, as mutations accumulate and tissue complexity increases, the immune system's reference becomes noisier, blurring distinctions between normal and abnormal cells. This context helps explain why viruses or cancer cells sometimes evade immune detection and why immune-related diseases rise with age. The immune system monitors biomolecular patterns and damage signals, detecting sharp deviations rather than slow, subtle changes, which may allow mutated cells to escape early immune elimination. Dr. Krummel describes the immune system as a constant curator, sensing not only pathogens but also tissue health and metabolic states. Throughout life, immune cells interact with commensal microbes, regulate tissue repair, and maintain homeostasis. The immune system's interaction with the nervous system extends to modulation of brain function, where immune molecules influence neural activity and behavior. The immune response is contextual and highly nuanced, not simply an on-off switch, but a spectrum of states that include tolerance, quarantine of microbes, controlled inflammation, and full activation. This complexity helps explain how the immune system balances protection with the risk of causing damage to tissues, as seen in chronic inflammatory diseases and autoimmune conditions. Sleep is profoundly important for immune function. During sleep, immune cells redistribute, many migrating back to the bone marrow, while neutrophils and other cells pop. The thymus plays a central role in immune development by generating and educating T cells to recognize self-antigens without attacking host tissues. This organ is largest and most active in early life, producing a vast repertoire of T cells necessary to respond to new pathogens and maintain tolerance. With aging, the thymus involutes and diminishes in size and output, reducing the influx of naive T cells into the immune system. This decline is correlated with increased susceptibility to infections, cancer, and diminished vaccine responses in older adults. Therapeutic interest in revitalizing thymic function includes potential methods to restore T cell diversity and responsiveness, which could improve immunotherapy outcomes and immune resilience in aging populations. Some approaches involve peptides derived from the thymus, although evidence and clinical applications remain in early stages. Emerging research reveals bidirectional communication between the brain and immune system. Notably, neurons in the insular cortex can influence immune states in peripheral organs through autonomic pathways, particularly the vagus nerve. This neural immune axis allows physiological states and even memories associated with immune responses to modulate immunity. Experiments in mice have shown that reactivation of brain circuits linked to previous inflammatory events can recapitulate immune states in corresponding tissues. This connection provides a mechanistic basis for phenomena such as placebo effects, stress-induced immune modulation, and the therapeutic potential of meditation and breath control in immune-related disorders. Autoimmune diseases arise when immune tolerance fails, leading to inappropriate attacks on self-tissues. These conditions have heterogeneous origins involving genetic predispositions, environmental triggers, and complex immune dysregulation. Examples discussed include psoriasis, asthma, lupus, and inflammatory bowel disease. Dr. Krummel notes that autoimmune diseases often represent immune archetypes, specific immune cell configurations and signaling patterns. These can influence disease phenotype and treatment responsiveness, explaining variability among patients. Treatments targeting immune pathways, such as cytokine blockers, can be effective but are complicated by individual differences and partial responses. Intriguingly, some autoimmune traits may confer evolutionary advantages by enhancing resistance to infections, illustrating a trade-off between immunity and autoimmunity. The conversation delves into the nuanced discourse around vaccines, acknowledging widespread acceptance among many parents alongside legitimate concerns about timing, combinations, and individual responses. Challenges in public communication include polarization, misinformation, and historical mistrust stemming from medical injustices. Dr. Krummel emphasizes the need for transparent scientific inquiry into vaccine scheduling and combination effects, advocating for open, nuanced discussions supported by rigorous data. While vaccines have unequivocally reduced morbidity and mortality from numerous infectious diseases, ongoing efforts should improve safety profiling, public trust, and tailored vaccination strategies. The immune system's complexity implies that vaccine timing and adjuvant effects could influence outcomes, particularly in vulnerable populations such as infants and the elderly. Dr. Krummel offers reflections on the nature of scientific research as a process marked by repeated failure, incremental progress, and the occasional transformative breakthrough. He underscores the importance of curiosity-driven basic research and interdisciplinary exploration, cautioning against reductionist expectations for simple, one-step cures. He acknowledges the tension between the deep complexity of biological systems and the constraints of funding, publication, and public understanding. Computational tools and machine learning aid in mapping immune networks and predicting intervention outcomes, but cannot yet replace experimental validation or capture the full multidimensionality of living systems. Effective science communication is highlighted as vital for bridging the gap between discovery and public comprehension, overcoming mistrust, and inspiring future generations of scientists. Emerging therapies involving peptides and stem cells hold promise for modulating immune function and tissue repair, but require careful consideration of context, timing, and immune compatibility. The immune system's vigilance against altered or foreign cells presents challenges for regenerative approaches. Dr. Krummel touches on the banking of umbilical cord stem cells and thymic tissue as potential future resources for personalized therapies, but cautions that technological limitations, safety, and ethical considerations remain substantial obstacles. Stem cell-derived organoids and induced pluripotent stem cells, iPSCs, offer experimental models and therapeutic potential, although genetic mosaicism and mutation accumulation can complicate their reliability and applicability. Spatial organization is integral to immune function. While many immune cells circulate through blood and lymph, substantial populations reside permanently within specific tissues, providing localized protection and maintaining homeostasis. This spatial compartmentalization means that transplanted tissues or cells require proper microenvironmental support, including blood supply and immune acceptance, to survive and function. Location influences immune cell behavior and intercellular communication, affecting therapeutic strategies involving cell or tissue transplantation. The immune system can form structured cell clusters resembling neural networks that coordinate collective responses, highlighting the complexity of immune spatial biology and intercellular signaling. The nervous system's modulatory influence on immunity extends to how psychological states, memories, and meditative practices may impact immune function. Activation of specific brain regions can alter immune responses, suggesting pathways by which stress reduction and mental conditioning could support health. Dr. Krummel and Dr. Huberman note growing empirical evidence that recalling immune-associated memories can evoke physiological immune activation, offering new frontiers for psychoneuroimmunology and integrative health interventions. Throughout the discussion, Dr. Krummel stresses the importance of foundational health practices, sleep, nutrition, exercise, stress management, as essential for immune competence and overall well-being, even as advanced therapeutics evolve. He expresses cautious optimism about future developments in immunology, cancer therapies, such as CAR T-cells, regenerative medicine, and computational biology, while emphasizing the ongoing need for rigorous experimentation, critical analysis, and responsible communication. The integration of artificial intelligence and machine learning promises to accelerate discovery, but depends on quality data and human judgment for interpretation and application. Dr. Krummel reveals that his dedication to public education arose from a desire to bridge the gap between complex scientific knowledge and public understanding. He highlights the challenges in communicating nuanced science amid societal mistrust and polarized discourse. His Substack and other outreach efforts aim to make immunology accessible and relevant, combating misinformation and inspiring informed engagement with health science. He advocates for scientists to cultivate empathy and clarity in communication to foster trust and appreciation of science's role in society. The immune system exemplifies biological resilience, navigating constant challenges while maintaining function amid environmental fluctuations and internal mutations. Phenomena such as autoimmunity and cancer illustrate the delicate balance immune responses must achieve. Adaptive diversity within immune mechanisms and human populations underlies both vulnerabilities and strengths, shaping evolutionary fitness and health outcomes. Understanding and harnessing this complexity requires sophisticated, integrative approaches, combining molecular, computational, and clinical perspectives.